Welcome everyone, myself Sudhir. Today we'll explore how machine learning and genetic programming can be used to automate breast cancer in diagnosis. This research integrates academic analysis with practical tools. Next introduction. Breast cancer is the leading causes of the death among the women worldwide. Accurate earlier diagnosis improves the survival rate. This study combines the genetical programming with machine learning to automate the diagnosis. Future selection method. We explore the various future selection techniques to identify the most relevant future per classification. Those are PSO, genetic algorithm, elementary programming, best first. Hybrid method improve the model performance. PCA and recursive future elimination. Next topic is machine learning models. We elevated several machine learning algorithms for this task. Those include the basic models like logistic regression, supportive vector machine, random forest, extra trees, and LDA. Model elevation. Elevation involves testing the model on unseen data using metrics such as precision, recall, and F1 score. This is the output. Confusion matrix heat map. Heat map show the true positive, false positive, etc., making it easier to understand the model performance. Class distribution visualization. A count plot shows the number of the benign versus the malignant cases. Helps identify the classes imbalance issues. Next model is accuracy comparison. A pie chart illustrates accuracy percentage of different models for quick performance comparison. Next model log loss comparison. Bar plot used to compare classifiers log loss values. Lower log loss indicates the better probability estimates. Next model is learning curve for logistic regression. Learning curves show the training versus the validation accuracy as data size increases, highlighting the overfitting.
Welcome to this deep dive into how machine learning can help diagnose breast cancer with greater speed and accuracy. In this video, we will walk through a video old data science workflow using Python and popular libraries like Pandas, Seaborn, Matplotlib. We will begin by importing and exploring a real breast cancer dataset. You will learn how to visualize the data, clean it, and prepare it for modeling. Then we will train and compare three powerful classification algorithms that are logistic regression, support vector machines, and random forest. We will take further by visualizing confusion matrix, plotting learning and validation curves, and even creating performance comparisons using pie charts and bar plots. Now let us start how to develop a classification model for breast cancer. Import libraries. This section imports necessary libraries for data manipulation, visualization, and machine learning. And Pandas is used for data handling and analysis. NumPy is for numerical operations. Seaborn and Matplotlib are for data visualization. Modules from scikit-learn and important for tasks like data splitting, pre-processing, model training, and evaluation matrix, classification report, and confusion. Import dataset. This line reads the breast cancer dataset from a CSV file into a Pandas data frame. And the next, explore data. These lines perform basic data exploration to understand the structure and content of the dataset. DF shape shows the number of rows and columns. DF head displays the first few rows. DF tail displays the last few rows. And DF columns lists the names of all columns. DF describe provides statistical summary of numerical columns and visualize data. This creates a pair plot to visualize the relationships between different features and the target variable. And the next, encode categorical values. This use label encoder to convert the categorical diagnosis column, which likely contains and into numerical values 0 and 1. And the next drop drop irrelevant columns. This removes columns that are not needed for the model training, such as ID and unnamed 32. Features and target. This separates the data set into features X and target variable Y. Normalize feature values. This uses standard scalar to normalize the features. This is important for many machine learning algorithms as it scales the features to have zero mean and unit variance. And the next is train test split. This splits the data into training and testing sets. The training set is used to train the models, and the testing set is used to evaluate their performance on the unseen data. The next is model training and evaluation. This section trains three different classification models: logistic regression, support vector machine, and random forest. For each model, an instance of model is created. The model is trained using the training data. Predictions are made on the testing data. The accuracy of the model is calculated and printed. Detailed report, that is random forest. This section provides more detailed evaluation metrics for the random forest model, including the classification report and the confusion matrix. The next one is plotting confusion matrix heat map. This visualizes the confusion matrix for the random forest model as a heat map, which helps in understanding the model's performance in classifying begin and malignant cases. The next one is count plot for target classes. This visualizes the distribution of the target classes in the dataset. Here we can see the picture of confusion matrix heat map random forest. The next one is count plot for target classes. This visualizes the distribution of target classes in the dataset. Here we can see the chart of count of diagnosis classes. The next is correlation heat map. This visualizes the correlation between different features in the dataset, and the heat map can help identify high correlation features. Here we can see the picture. Accuracy scores and pie chart. This calculates and stores the accuracy scores of the trained models and then visualize them as a pie chart to compare their performance. Here we can see the pie chart, that is accuracy distribution of classifiers. Next one is log loss bar chart. This calculates the log loss of logistic regression and random forest and visualize them in a bar chart. Log loss is another metric to evaluate the performance of classification models, particularly for probabilistic predictions. Here we can see the bar chart for logless comparison of classifiers. Validation curve or logistic regression. This section plots a validation curve for logistic regression to assess how the model's performance on training and validation sets changes with the size of the training data. Here we can see the chart of validation curve logistic regression. The next is scatter plot of mean radius versus mean texture. This visualizes the relation between radius mean and texture mean features, color coded by the diagnosis to see if these features can help distinguish between some cases. Learning curve, logistic regression. This section calculates the plots of the learning curve for logistic regression and also showing how the training and validation accuracy change with the number of training samples. This helps in identifying the issues like overfitting or under. We have taken a complete journey through a breast cancer diagnosis pipeline using a machine learning. We started by exploring and cleaning the dataset, then applied normalization and feature selection to prepare it for training. And then we evaluated three powerful classifiers: logistic regression, vector machine, and random forest, each with different strengths in accuracy. Along the way, we visualized key metrics like confusion metrics, ROC curves, and log loss charts to compare model performance. And also, we use heat maps and learning curves to understand features relationships and how the models learn from the data. Thank you.